So we finish almost all the material in section 2.7. At the end, we're using a example to do a small practice, to make sure everything you understand is properly, okay? So this example is as following. So I know T0 is hold this value. From the representation of this value, you will know that it's a hexadecimal. And then you will implement this sequence of instructions and try to calculate what the value is T1. So I wanted to pause here, try to solve this problem by yourself, and then continue with this video. So basically what we do here is we try to do set on less than T1, T0, 0, and T0. So what it basically means is I try to compare 0 and T0. If 0 less than T0, I will set T1 as 1, otherwise T1 will be 0. Right? So again, T0 is represented this way as a hexadecimal, and the value, the sign value is a 0, which is sign bit is 0, therefore it's a positive value, right? Therefore T0 is less than T0, which is a positive value, therefore T1 will be 1. Okay? So now I continue. Branch if not equal T1 0 else. So basically if T1 is not equal to 0, I will branch to this instruction with the label else. Otherwise, I will continue with the next instruction, which is jump. And we know T1 is 1, therefore this condition satisfied, right? T1 is not equal to 0. Therefore, I will branch to the instruction with the label else. And then I will begin to implement this instruction, which will be calculate the addition immediate between T1 and 5 and using that value to update T1. We know until now T1 is 1, right? So 1 plus 5 is 6. Then using that value to update T1, then the final result of T1 will be 6. So that is shown as the following. I hope it is clear to you. If it's not clear, please let me know. So now we continue with the next section 2.8, supporting procedures in computer hardware. First, I want to talk about what is procedure. Procedure basically is function. Basically, it has a set of instructions and work together as a function. And so for example, right, I want to implement, for example, the sorting procedure from high-level perspective. And then, in the sorting one inside, you always has the switch, the swamp, right? So I have two options. One is every time I implement that, I will, let me just put a pen here. So there's two ways to do that. So one way is every time I implement the instructions, I will put the swamp, the detail of the implementation of the swamp. Of course, the lower level language compares the swamp operation inside the main procedure, the main sequence of instructions, right? So the basic, for example, if here those kind of few instructions together to realize my swamp, this function. So if I using the the regular way, so basically every time I implement the sequence instruction, I will include all the detail of this form functionality one inside the main procedure. There's another way to do that is I just combine them or binding them together and with another sub procedure I call the swamp, right? And then instead of I include the detail of the swamp inside the main procedure, what I do is when I try to implement the swamp, I finish the first instruction, right? And try to implement next one will be the swamp. I will, instead of embedding the whole sub instruction in here, I will call the swamp, right? So here is I just call a sub procedure swamp. After I do the call, so basically what they do is, so they will directly transfer the control from the main procedure into the first instruction of the swamp, this whole set. And then I will begin to implement the swamp instruction one after another until I reach the last instruction included in this subprocedure swarm, I will jump back to the main procedure and then continue with the following instructions. So let me say one more time. The procedure is just like a function in your or method in your Java, and basically means I kind of bound multiple fundamental instructions together in order to realize certain predetermined function. And by doing that, we are able to directly call this sub-procedure, implement this kind of predetermined functionality, rather than embed all those individual instructions within this sub-procedural function into the main procedure. So, for example, here I implement the certain instruction in the main procedure. As long as I want to use the functionality of swarm, I directly call this swarm. This is from the low-level language we call the procedure. So we call this swarm, this sub-procedure, and then the whole control will transfer from the main procedure into this sub-procedure which calls swarm, and begin to implement the instruction one after another. After they implement all the instruction within swarm, this sub-procedure, they will jump back to the main procedure and continue with the other instructions. I hope it's clear. It's just try to optimize the optimizing of the instructions, right? So basically, instead of I treat them equally, I kind of combine them based on their purpose or functionality. Then I will treat the whole block of the instruction as a whole and treat it as a procedure. So every time if I want to implement that, I just jump this procedure. After finish, I will jump back. I hope this is clear to you. So now, in this slide, this kind of explain why we want to use in the procedure this kind of organizing tool, right? Basically, because it's able to make the program is easier to understand, because rather than the individual instruction together, it kind of like multiple procedures with a well-organized structure. And also, it's allowed the code to be reused, right? Because if next time another main procedure you also want to use in this sub-procedure called swarm, you still can directly call that rather than embed all the individual instructions inside, right? Also, it's allowed to focus on the one portion of the task, right? Because it's kind of maintain the whole procedure as a hierarchical structure and the parameters as the interface. Okay, so now let's try to think. I hope until now you already understand what means procedure. Basically, it's a bunch of instructions together to realize certain function. And this bunch of instructions can be called by the label of that procedure and can be reused for the different programming environment. So now next I want to explain a little bit how this procedure can works. Okay, so basically, so I have the main procedure, right? And I have some sub procedure, and in sub procedure it has the label L. The label L represents the label of the whole this sub-procedure, but at the same time, this label L is also the label of the first instruction in this procedure. Okay? So now what I do is when I jump to the certain step in the main procedure, now I begin to using the functionality of this sub-procedure, I will begin to call the label of this procedure. Okay, so by doing that, what I actually try to do is this main procedure we call the caller. Okay, so it means the program called the other one. And then the sub procedure we call callee. Basically is a set of the instruction be called by the other one. Okay, so basically the first will be the caller and will be called the callee, right? After that, after the callee finished, it will return some results, right? and that result is called the return value. Okay, and some procedure does not have this kind of call. Okay, so basically you will implement the procedure straightforward. That way, that procedure called the leaf procedure. Normally, callee is a leaf procedure because they don't have the other procedure embedded in this procedure, but they always be called by other. So this kind of is no procedure call inside that kind of procedure called leaf procedure. If, for example, color will be non-leaf procedure, we call the nested procedure because there is a procedure called inside. Okay, so now let's repeat one more time. So 5 key terms. First, color means the sequence of instruction need to call the other procedure. So that the main procedure called color. And the procedure be called, that called callee. And normally callee is called leaf procedure because there is no procedure called inside. And the color is normally is a nested procedure, what we call the non-leaf procedure, because it always has the procedure called inside color. And sometimes the callee, after finish this instruction, we will return some value, and that called the return value. I hope this is clear to you. So now we say based on those kind of terms we have learned, let's see how we can describe this the whole procedure call. So the first is the caller need to call the callee, but before that, it might need to transfer some information, which is arguments can be used by callee, right? Basically, the first step will be caller will be prepare some arguments. Those argument potentially will be used by callee, and then they will call callee. Basically, when they call, potentially what they do is they will transfer the control from the main procedure, or we call caller, into the first instruction of the sub procedure, or called callee. After the control transfer, the callee will begin to require the necessary memory in order to finish their implementation. After that, they will begin to implement whatever the functionality need to implement. And then they will transfer the control back from the callee to caller. But before that, they will prepare the return value. And after the return value prepared, they will transfer to the caller. After that, basically the control transfer return back to caller, they can be implement the other instructions in the main procedure. But here actually I make 2 procedure kind of vague. One is prepare the argument in order to make sure callee can use. Another is the prepare for the return value to make sure caller can receive that return value. So before explain that, I want to explain how this call callee and the return value can implement. Okay, so what kind of instruction I can use to realize this kind of caller to callee? So that the instruction called the jump and the link. So basically, when the caller call callee, they will implement this jump and link. So what this one try to do is they enable the control transfer from the main procedure into the sub procedure we call callee. That is where the jump referred to. Why call the link? Because you need to make sure before you jump, you need to make sure your callee, after finish everything, they are still able to return back to the main procedure appropriately. If assume the current procedure has the memory address stored in PC, the program